Swayam Prabha, free DTH channel for education.
Mainly, we are trying to focus on the transport equation, heat equation, wave equation, Laplace equation solutions. So, how do we solve that? Okay, so that's the one we are going to discuss today. First thing we are going to discuss about is the first order linear ODE with constant coefficients. How do we solve that problem? Okay, let's see that one first, and then we'll go for the heat equation and wave equation. So let us start. So first order linear PDEs, okay, with constant coefficients, which is of this. So in general, the linear PDEs of this form, okay, A of x comma y into ux plus b of x comma y into uy plus c of x comma y into u equal to f of x comma y. So this is the general form of the first order linear PDE, okay, where x comma y belongs to some subset of R square. So yeah, this is called the first order linear PDE. Okay, so what we expect is that we want that u to be at least one time differentiable. Means C1 of omega means it is continuously differentiable. Okay, differentiable and then it should be continuous. So we expect a u belongs to C1 of omega such that u satisfies this one. So then we say that if such a function is going to exist, okay, either it can be u of x comma y equal to, you can write this like u of x comma y equal to something, okay, or you can write like u of x comma y comma u also you can write it, okay. So in that case also we can say that u of x comma y comma u also you can write it. So this can be like explicit form, this can be implicit form also. Both ways you can write it. So in that case, this u, okay, this u, this is called integral surface, okay, or the solution surface. Like the same way what we did in the OD case. So there we got this catch of x, and then that we said like if it is satisfying all the properties, then we said that it is going to be the solution of the ODE problem. Similar to that here, but here only difference is that there it was catch is a function of single variable, here it is a function of two variables. Okay, so this is the first order linear PDEs in two-dimensional, two variables. Okay, so that's the one. Now suppose you are a of x comma y and b of x. Okay, so this is cards. For example, I can take this from aux plus buy equal to 0. Let's take this problem. Okay. So here a and b are constants such that a square plus b square not equal to 0. So this is chosen essentially that a square plus b square is not equal to 0. We are choosing such a and b are constants such that a square plus b square is not equal to 0. So this equation is mostly called as the advection, convection or advection or transport equation, which we'll see it. How do we get this one? We'll see it in the transport equation. Okay, once I will just give a simple derivation within 10 minutes. Okay, so that's what we are going to see. Now, how do we obtain the solution for this problem? See, the same problem I can translate into this way. Okay, I can write this as a comma b, okay, into ux comma uy. Okay, a comma b into ux comma uy equal to 0. This way I can translate this problem. Let us have a geometric view of this one. Okay, what does it mean? I have a vector, okay, a comma b is a vector, and ux comma uy is another vector, and if I take the dot product, that is becoming 0. That means what? A comma b is perpendicular to ux comma uy. In general, if you are writing the u is a vector, u is a scalar function, then you can write del u. Okay, del u can be written as dou by dou x, okay, dou by dou y of u, okay, or I can write as dou u by dou x, dou u by dou y. Okay, so this is the thing, but del u I used to write. This is called del operator. Okay, del operator is the gradient operator. Say, so this I can write it as, okay, therefore this I can write as a comma b dot del u equal to 0. I can write it. Okay. So what does this equation geometrically represent? It means you have, if I just write this as a directional derivative, okay, there's a thing called directional derivative. So in directional derivative form, what I can write is that I can write this as dv of dv of u of x comma y again, this one. Okay, dv is nothing but a comma b, where b is nothing but a equal to 0, where a comma b equal to a comma b. Okay, means what does it meaning is that the u is vanishing in the directional derivative of u in the direction a comma b is 0. Okay, that is nothing but the directional derivative which we have. So dv of u comma x comma u of x comma y equal to 0 in the direction of a comma b. So that means if I have a solution, okay, the solution along this direction b, okay, the solution must be constant along the direction b. So that's what we mean. Okay, so dv of u comma u of x comma y equal to 0 means the solution of u is constant along the direction of b. Okay, constant along the direction. Therefore, what you are going to have, you are going to have some relation now. Okay, what we are going to see now, we are going to see if it is constant, whether it is going to be unique or not, that we need to see. Okay, it is saying that the u is constant along the direction b. What we need to look into is what are those directions, what are the lines parallel to vector. So that direction may be like infinite number of vectors we will be getting. So let's see that. So what we need to find is that we need to find a solution for this one. What are the solutions possible? So for example, I can take v equal to ab. Okay, v equal to ab is my vector is given. Now what are the points which is passing through? Okay, through a point x comma y, x1 comma y1, and through parallel to this vector, lines parallel to this vector and passing through the point x1 comma y1. So that one from your school mathematics you might have studied this one, or some of the physics problems also you might have studied. So x minus x1 by a equal to y minus y1 by b. Okay, this is nothing but the lines parallel to the vector b, okay, and passing through the point x1 comma y. This you might have studied in your school geometry. So now what we have, x minus x1 comma y1 minus y1 equal to, therefore what you can get is that you can just simplify this. So we are going to get bx minus ay equal to ax1 ay1 plus bx1 is going to come. Okay, so some manipulations you are going to do. Then what you are going to get is that you are going to get bx minus ay equal to c is going to come. Okay, this is your equation is going to come. Bx minus ay is going to come. So that means any line parallel to the vector b, okay, has the equation of this form. This is the equation when any line is parallel to the vector b equal to ab has this form. So also we know this one. Okay, we know this one. Suppose you have a vector a comma b is a vector. Okay, then the corresponding perpendicular vector for this one is nothing but minus b comma e. So in this case you can see that a square plus b square. Okay, a square plus b square is sorry, b comma minus a is going to come. Okay, so in this case what you are going to get? You are going to get the equal to 0. Okay, so equal this is going to be 0, means b minus a is the normal vector to the lines parallel to b. So if you have any line parallel to the vector b, okay, then your perpendicular vector is going to be like b minus a pattern. Okay, any line parallel to this. So therefore what you are going to get? You are going to get since c is an arbitrary constant, what you are going to say is that you are going to get a family of parallel lines. So the c is arbitrary constant, therefore you are going to get a family of parallel lines that is going to. So these lines are called characteristic lines. Okay, therefore what you are having, you are going to have many such lines. You are going to have many such lines. Okay, so these are all like it is parallel to. So if I have the vector b, okay, b is nothing but a comma b, then these are all the lines, family of lines I am going to get. So these are called the characteristic lines for this equation, for this equation. So note that here what we are going to have. So AB minus BA is fine. Okay. So okay. So note that here. So you can see that the vector parallel to this one. These are all characteristic. I have something in the red color. I don't know whether you can see that. So in the red color, I have given a vector b equal to a comma b. So along that direction, okay, parallel to the direction, you have plenty of lines are going to be there. So those are all called characteristic lines for this region. Therefore, what we are expecting is that now here we are expecting that u of x comma y equal to c is ex. Okay, because along the line, along the vector, okay, v equal to a comma b. Okay, u of x comma y is constant. b equal to a comma b. dv of the direction of u of x comma y is equal to 0. Therefore, u of x comma y equal to c along the direction of that b. Okay, so u of x comma y starts in the direction b. Therefore, we know like what all the things is going to happen. Okay, if it is constant along this direction, therefore this is constant along this line also, this line also, this line also. Therefore, you are going to get your u of x comma y is going to be of the form. Okay, it is going to be of this form. F of some function of bx minus ay is going to be. Okay, you can verify that. You can verify that. You can take ux for this one. Okay, if you are taking ux for this one, you are going to get something like ux is going to become like f dash bx minus ay into b, okay, and uy is going to become like f dash into bx minus ay into a minus a is going to come. So you can just sum it up, multiply by a, so it is going to become like ab, this is going to become like minus ab, so both are going to get cancelled, so you are going to get the answer is correct. Okay, the f is an arbitrary function. So you can verify this one, ax plus by is equal to 0, therefore it is going to be satisfied. So now what we have, so the method which we used here, okay, the method which we used here, the underlying method, underlying concept of the method of characteristic, what we are going to do is that. So this is the method which we find for the solution of the problem already. Okay, now we are going to do one more similar kind of method, which is called method of characteristic. So the underlying concept of method of characteristic is that, so this is not only for this linear PDE or first order linear PDE, we can use it for the non-linear PDEs also, or quasi-linear PDEs also. You can use the same concept. Okay, that if you want more details, you can again you can refer my PDE lecture notes or some of the PDE lecture PDE textbooks also you can refer. So that is called method of characteristic. So the underlying concept of method of characteristic is that, as I mentioned in the last class, whenever you are solving the PDE, what you are going to do is that you are going to you are going to translate the problem into a ODE problem. Okay, you are converting the PDEs into ODE problem, and then solve that system of ODE or ODE, and then bring back to the give the solution for the PDE. Okay, that's the underlying idea. So method of characteristic also going to do the same thing. Even if you see the next few minutes, you will see the variables method also. In that case also. In that case also, we are going to see the same thing. Okay. So now what we are going to do is that if you want to find the ODE problem, here there are two variables are okay, x and y are there. So in the case of ODE, I need to have only one variable should be there. So that means what I need to do is that I need to eliminate one of the variables from here, and I will convert that into a ODE problem. Okay, so what we need to do in order to convert an ODE problem, you need to eliminate one of the constant, one of the partial derivative. Okay, one of the partial derivative, either ux or uy, just get rid of it using some manipulation. Then you can transform it to a ODE problem, solve that ODE problem, and then bring back to your original system. Okay, so here what we mentioned is that since the directional derivative vanishes along this direction b equal to ab, in this direction it is going to vanish b equal to ab. What we are going to do is that we are going to transform the coordinate system. Okay, we are going to so this is in the xy coordinate. This problem is in xy coordinate. Okay, x comma y coordinate is there. Now I'm going to transform it to some other coordinate called eta chi comma eta coordinate. Okay, in the chi comma eta coordinate, what I'm going to do is that I'm going to obtain I'm going to translate this problem into that domain, and then try to see what is the solution is going to come. So since b equal to a comma b, what I can do is that I can find the corresponding coordinate. Okay, how do I find is that since b equal to a comma b, my coordinate what I'm going to do is that one coordinate I'm going to take it in this direction. Okay, so since it is a coordinate, okay, therefore it should be perpendicular. What I'm going to take, the another coordinate I'm going to take a perpendicular. I know this vector chi is going to be something a comma b. Eta I'm going to take it in this direction because chi is a comma b and eta is b minus a, then they are going to be perpendicular. Okay, so I'm going to take that. So if I want to take it to any other any other vectors in that coordinate, what I'm going to do is that I'm going to take a dot product of that one. So that for chi comma eta is going to become, take a dot product with a comma b, that is going to be with b comma minus a. Okay, so that is going to give you the direction any system. If you take any vector in x comma y, okay, if you take any vector in x comma any point in x comma y, okay, this is xy coordinate system. then that can be translated into chi comma into using this transformation. Okay, you can take a dot product with them, then that's automatically going to give that. So that is going to become like kx plus by and bx minus ay is going to. Okay, therefore your chi is going to be ax plus by and eta is going to be bx minus ay is going to. Now you can translate this problem. Okay, you can translate the corresponding thing. What you need to find? You need to find u chi and ux and uy. Okay, if I find ux and uy, let us see this one. So ux and uy is going to be ux is going to be u chi x, okay, plus u eta x is going to come. U chi as it is, okay. Chi x is nothing but a is going to come, okay. Therefore, this is going to become like the into a plus b. This is going to be eta x is going to become b. Therefore, this is going to be like b u eta. Similarly, a y is going to become like u chi y plus u eta y is going to come. That is going to become like once again b u chi b plus minus a u eta is going to come. Okay. Now, if you sum this together, multiply and sum it, multiply this by a and multiply this one by b. So then what you are going to get is that you are going to get a square. I can just sum it up together. A square plus b square into u chi. Okay, plus again here this is going to become like ab and minus ab. They are going to get cancelled. Therefore, you are going to get only a square plus b square u chi equal to 0. So now you remember that I have chosen my a square plus b square not equal to 0. Therefore, this is not equal to 0. Therefore, only this is going to become 0. Therefore, what you are going to get? You are going to get u chi equal to 0. If u chi equal to 0, already we saw it in the last class. If u chi equal to 0, you can see that u is going to be constant. Okay, but with respect to the second variable. Okay, if I integrate this one, I am going to get a constant. U equal to constant is going to come, but it's a partial derivative. Therefore, it is going to be a function of some other variable is going to come. Okay, the second variable is going to come. So you can just differentiate this one. If I take u chi, that is going to become 0. Okay, but what is chi? Chi is nothing but bx minus a. Therefore, u is going to become like f of bx minus a. I got the earlier in the earlier method also I got the same thing. In this method also I got the same thing. Okay, u equal to bx minus a is the solution for this problem. Okay, so this method is called method of characteristic. Okay, the method which we described now, translating it into a ODE problem and then solving it. Okay, this I have translated into a ODE problem and then I solve that problem. So that is called method of characteristic. And this coordinates, okay, this chi and theta is the new coordinate, that is called characteristic coordinate. Okay, these are called characteristic coordinate. You remember this in our first class or the last class, we solved this kind of problem, ux plus uy equal to 0. So in that case, we have mentioned that f of x minus y is the solution for this problem. So that a and b are 1, therefore we are going to do this. Okay. Any doubts on this one? Okay. Next, we are going to see transport equation. So transport equation is a similar one. Okay, the same kind of thing which you are going to see. I'm just going to give a brief description about the transport equation because this is going to be helpful to some of the civil engineers or super mechanical engineers who is working on this transport equation problem. So what we have is that you have something like I don't know, like I will just show some okay, so now let's see the transport equation. Okay, this is one of the important equation in the first order PDE. Okay, so you see that what is the transport equation. So I'll just try to explain that using a simple story. Okay, have you heard of the story? Have you heard of the story of Ant and Dove? In the school days or childhood, Ant and Dove story. Okay, if not, I'll just tell you. From that, we are trying to derive the PDE, okay, transport equation derivation. Okay. Okay, so are you able to see my screen?
Yes, sir.
Okay, so this is the story of Ant and Dove. Okay.
Sir, sound is not coming with me.
No, I didn't put the sound. Okay. Just animation only. Just see that. Okay. Okay, so this is the story of this ant and dove. Okay, one ant will be falling from the tree when it was trying to do, or in the bank. Some different places, different story will be there. One sec, I have friends. What we have is that suppose you assume that you have a small tube. Okay, small tube is there. This is the same thing for the concentration which you are using in the chemical engineering also is going to happen, or some of the problems in mechanical engineering also will be useful, like a fluid dynamics problem which will be solving. I hope you are studying already the computational fluid dynamics course as a course, okay, compulsory course probably. So in this case, what we have is that what I have a small tube. Okay, I have a small tube. In that, what I'm going to have is that I'm going to see how the pollution or some mass concentration is going to happen. Okay, so that's the thing we are going to see. So you can see that we are going to revisit the same problem. So earlier we solved this problem, AUX plus DUY equal to 0. Remember this one. Okay, and then we solve the problem like U equal to f of bx minus uy. So that's what we are going to derive again. Okay, here now what I am going to take is that I am going to solve this, obtain this problem, at plus cux equal to 0. Okay, so now what I'm going to do, I'm just going to derive that little bit. How do we get that? So consider the dynamics of the concentration of your pollution in a stream of water flowing through the thin tube. So for example, you can just see that this is the ant is there. Okay, this is a small ant is there, which is going to flow across the river. Okay, across the river fluid is going to go. Now you can just see that the same. You can consider the ant as a pollutant particle, either it is air pollution or water pollution. Some particle is going to be there in the flow of the river or flow of the air. Okay, it is going to be there. So small concentration is there. Is dynamics of the concentration of a pollutant stream we are going to see, which is, let's say, like a thin tube is there, which is the pollutant is moving at a constant speed. Of course, it is we are not going to. I'm not going to say like the dispersion etc. are not concentrating. Okay, I'm just saying that this is a mass particle which is going to be there. Okay, but in the reality, there will be dispersion will be there. So once it is going across here, this is going to disperse. It is not the case I'm going to consider. I'm just trying to consider this going across the same direction. Okay, so it's not going in different direction. I'm not going to consider. I'm just considering only one direction I'm considering. But t is there and x is there. Only x direction only I consider. Okay. But in reality, we have like other directions be there, so I'm not going to consider that. So u of x comma t, I'm going to denote. Okay, so for this problem, I'm going to take u of x comma t is nothing but denote the pollutant. Okay, the concentration of the pollutant in kilogram per minute at unit time. Okay, kilogram per meter per unit time. Okay, mass per unit. So if I just see, suppose I consider this interval, small interval, I'm going to see. Okay, in this interval, a comma b, how the pollutant is going to come. Okay, so it is going to be I have to see. So it is going from here to here. Therefore, I need to know like what is this is a per unit mass it is there. Therefore, if I want to concentrate on this interval, therefore what I can do is that I can just do the integration. Okay, integration of u of x comma t is going to give me the total pollutant. Okay, the total pollutant in this interval. Okay, that is going to be there. Now once the time is moving, this is going to move. Okay, whatever is there here, this is going to move from here to here. Okay, so like the way the ant was moving. So once it was falling down, so it was in some interval. Once time is approaching, then it is going to move away. So in that case, the ant has to put the leaves in the proper location so that it can capture them. Okay, the same thing here. Suppose you want to capture some of the pollutants, etc. The same kind of logic you are going to use. So you need to understand how fast the flow is there and how fast the pollutant is moving, or the object is moving in that one, and then you have to get them. So this is nothing but the transport equation. Almost similar kind of things is there for the traffic flow problem also. In traffic flow problem also, you do the same kind of things. Okay. So due to the conservation of mass, what we have is that so the above quantity must be equal. So I'm going to take a small interval. Okay, I'm going to take a small delta t interval. I'm going to observe what is going to happen in that delta t interval. In delta t interval, what it is going to happen? Okay, the quantity, okay, the pollutant quantity must be equal to any of the pollutant after some time t also. The time and delta t times it should be same. Okay, so therefore, if I have this one, now I am just shifting it over here. Therefore, this interval I am going to call as a plus delta t and b plus delta t, because after time delta t, my pollutant will be moved over here. Therefore, I got to observe what is going to happen in that interval. Okay, so that I'm going to observe that. So according to that, it is according to the consideration of what mass, what you are going to get is that integral a to b of x comma t should be equal to integral a plus delta t b plus delta t u of x comma d plus delta t, because this is moved from this is at the time t. Now I got to observe that delta t times, okay, therefore I am going to put d of x comma t plus delta t into dt. Now if I differentiate this problem, okay, if I differentiate this problem, what I am going to get is that differentiate with respect to b only, because I need to understand what is going to happen at most at the end of the places that I need to understand. Okay, so therefore I differentiate this one with respect to b. So in that case, what I am going to have here, this is going to become like u of b comma t is going to come. Okay, in this side it is going to become like u of b plus c. Here what is going to happen? Okay, so one more thing we got to see here. Okay, so if it is moving with the speed, okay, if I move with the speed, like let's say this is moving with the speed of 1, okay, 1 meter per second. So in that case, I can use that as I can use this one. Suppose it is moving with other speed, like let's say c. For example, here I'm going to derive the c. So if it is moving with the speed c, then in that case I'm going to get c of delta t is going to come. C into delta t is going to come. Okay, c into delta t. Because this is going to become like, in that case, if it is unit, you are going to get delta t. If I'm moving with the speed of c, then it is going to become like, because it is a displacement, so that is going to become like unit speed means you are going to get a plus delta t, because distance is nothing but time into speed is there. Okay, so that one c to delta t is going to come. So this is going to, if I put c, then c to delta t is going to come. So in that case, I can rewrite this equation this way. Okay, so in that case, again you do the differentiation with respect to b. Therefore, this is going to become like u plus c into delta t, comma d plus delta t is going to be. Okay, so this is going to be my relation which I am going to get. Okay, so this equation, what is this equation is saying is that the concentration at the point b at time t, okay, is equal to the concentration at the point b plus c into delta t at time d plus delta t. Okay, so this is, you can expect that, because you can just see that this is the ant which is moving at the speed c. So you can just see that whatever the ant was here, the same ant is going to be here at that time. Okay, so that means I'm not assuming some dispersion, etc. I'm just going to say that this is going to be accumulated and it's going to travel together only. Okay, but once you come for the real problem, you can introduce the dispersions, etc. to come to the picture. Okay, here I am just taking some interval b. Okay, I'm just taking a comma b. So this b is arbitrary. I can take anywhere here and then I can observe it. Since b is arbitrary, I'm just going to replace that as follows. Okay, wherever b is there, I'm going to put that as x. So that is going to become like u of x plus x into c delta t, t plus delta t equal to u of x comma t is going to. Okay. Now what I'm going to do, I'm going to take a differentiation of this one. Okay, if I take a differentiation of this one, that means I'm just going to calculate this one, u of x plus c into delta t, comma d plus delta t minus u of x comma t is going to become 0. Okay, I'm going to divide by delta t, divide this by delta t. Okay, and allow delta t tends to 0. This is going to be your problem like dv u is going to, this is nothing but the definition of the directional derivative. So dv u is going to come. Okay, so that here v is nothing but c comma 1, because here you have c and here you have 1, therefore it is going to become like v equal to c comma 1, and u is nothing but x comma ux comma ut, therefore you are going to get your equation as dv u is going to become like, so this is going to become like ux ct one sec, ut plus cux is going to be equal to 0. So dvu is going to be ut plus cux. Okay, so almost same thing what we mentioned here. This is nothing but the transport equation. Therefore, you can see here the solution you can easily find out. Okay, so you can see that u is going to become like, you can verify this one, x minus ct is going to be the solution, because a is 1 here and b is c here, therefore it is going to be f of x minus ct. U is going to become like f of x minus ct is going to be the solution for this problem. Okay, so similarly, so f of x minus ct. So if I some simple problem, suppose some Cauchy condition is given, means the initial condition is given. So the Cauchy data is called as the initial condition. If the Cauchy data is given, for example, for this problem, they give the Cauchy data, means the initial condition is given like this: x if x belongs to 0, 1. Okay, and 0 if x does not belong to 0 comma 1. So in that case, you can just formulate this one. So e of x comma 0 is going to become like this would satisfy this condition also. Therefore, e of x comma 0 is going to become like f of x. Okay, f of x minus c, because here t is 0, therefore it is going to become like f of x. That is going to become like x if x belongs to 0 comma 1. Okay, and 0 if x does not belong to 0 comma 1. Therefore, e of x comma t is going to become like f of x minus ct. Okay, so therefore you can put this as equal to x minus ct if x belongs to 0 comma 1, and 0 if x minus ct does not belong to 0 comma 1. So that is going to be your solution for this problem. Okay. Okay. Next few minutes. Okay. So this is the equation which I have. So I can just see that how the equation is, the characteristic is going to be there. So you can rewrite that problem, whatever I have done. So you just rewrite that problem as x belongs to ct comma ct plus 1. So this one you can see that. Okay. So whatever is here, that is moving along the direction. So x minus ct is going to come. That means it is going to move along the direction of the flow is going to come. Okay. So that you can observe it from here. Okay. So these are the characteristics which I have made in the figure. Okay. Next one, we are going to see some problem. Sorry, some heat equation we are going to solve. Now we are going to go for another method called variable separable method. Okay. In variable separable method also we are going to solve the same problem. Okay. Our transport equation will solve it. So in variable separable method, this is also known as Fourier method. Okay. What we are going to solve is that we are going to solve this problem. Heat equation. Of course, we are going to solve all the other problems also. Ut plus c square uxx x belongs to 0 comma l. Okay, and t is greater than 0. And I am going to consider this problem only. Okay, and then I have e of x comma 0 equal to e of x comma 0 equal to f of x. Okay, where x belongs to 0 comma l, close to interval 0 comma l here. And then I have u of 0 comma t equal to 0. U of 0 comma t equal to 0 for all t greater than 0. Okay, and u of t greater than or equal to 0 actually, and ut of 0 ul of 0 comma t equal to 0. Okay, t greater than or equal to 0. Okay, so I have the problem. I have a heat equation. So I have a rod here. Let's say, okay, this is let's say 0 comma l is the interval, and it is given that this is obeying, this rod is obeying this heat equation. And at the initial time, I'm giving some constant temperature or some temperature. Okay, I'm going to give some temperature in this rod. Okay, and I have given at the end point the temperature is T. Okay, at both end points, I'm going to keep the temperature as T. This one we are going to solve. Okay, so before that, we will solve one more problem and then we'll go for this one. What I'm going to do is that I'm going to solve this is the separation of variable. So separation of variable means what I'm going to do is that, for example, in this problem, I have u is a function of x comma t is going to be there. U is a function of x comma t. This one I'm going to write it this way. It's a separable means I can write this as x of x comma into t of t. Means I can write this as product of two functions, both are independent of other. Means x is independent of t and t is independent of capital T is independent of small x. Okay, so such things if I write, that is called variable separable method or separation of variables method. Okay, so this method is also known as the Fourier method, and this method can be applied for any linear homogeneous PDEs also. Okay, again our problem is, as we did in the characteristic method or the transport equation solution which we found, same kind of things we are going to do. Here we are going to translate the problem from PDE to ODE and then we are going to solve the problem. So this is the problem I have. So before that, before solving this problem, let us solve a simple problem and then we'll go back to this one. So in general, if you have any PDE, okay, for example, if you have u of x comma y, in that case you can write u as a product solution. Okay, if you can write u as a product solution, g of x and h of y for some functions g and h, where g is independent of y and h is independent of h, then we can write that is called the product solution or variable separable method, etc. Okay. In general, if you have n-dimensional variables also, you can do a similar kind of thing. You can write ux1, ux2, etc. Even un, you can write that as g1 of x1, g2 of x2, etc. And then substitute and then you can find the solution for that. Okay. So this kind of method is called variable separable. So let's solve a simple problem. Whatever we solved in the earlier, the transport equation. So we'll solve it. Okay. So that is going to become like you have ux plus uy equal to 0. So I'm going to assume that u is of the form x of x into y of y. Therefore, ux is going to become like x dash of x, okay, and into y of y, and uy is going to become like x of x into y dash of y is going to. Therefore, you can substitute it over here. Therefore, this is going to become like x of x into y of y plus x dash of x dash of x into y of y, x of x into y dash of y is going to. Okay, now here dash denotes with respect to x, here dash denotes with respect to y. Okay, equal to 0 is going to come. So now I'm going to divide. So I'm going to divide by x of x by into y of y. I can divide this comfortably because I'm assuming it is not equal to 0. If it is equal to 0, your u is going to become 0. If it is y of y is 0, then this is going to become 0. X of x is 0, this is going to become 0. So I'm going to assume product is not equal to 0. That is comfortably you can assume that, because if it is that, then you are going to get only trivial solution. I'm not interested in the trivial solution. I'm going to find the non-trivial solution. So I can comfortably divide this. Therefore, I'm going to get here x dash of x is going to come divided by x of x is going to come. Okay, this is going to become like x dash of x by x of x, and this is going to become like y dash of y by y of y is going to equal to 0. So I can write this as comfortably x dash by x equal to minus y of y by y dash of y by, or y dash by y. Okay, I write it as y dash by y. So I can see that the left hand side is a function of x, right hand side is a function of y. Therefore, if both are equal, that means what you can say is that this is going to be some constant is going to be. Okay, some constant is going to come. U is going to be some constant you are going to get. It's independent of x and y, because this one is x, this side completely x, because x dash of x and y x of x is there. This side is y dash of y, that is completely y. Therefore, if both should be equal, then you should have that this would be some constants would be there. In that case, only you can just give that this is going to happen. Therefore, you can solve these two problems. So you are going to get x dash equal to ux, x dash equal to bx is one problem, and y dash equal to minus dy is another problem. So this one you can easily solve this problem. So if you solve this problem, you are going to get x equal to e power mu x is going to come. Okay, and here y is going to become like e power minus mu y is going to come. Okay, so if you solve this problem, I'm just ignoring some constants and all. If you have constant also, doesn't matter. Okay, you can just put some c1 and c2 and then you can get that also, doesn't matter. So in this case, what I am going to have x equal to e of x and y equal to e power mu y. So my product solution is this one. Therefore, if we substitute over here, this is going to become like e power mu x into e power mu y. That is going to become like e power mu into x minus y is going to. That's what we have said earlier also. If any solution is of this term, this is going to have this term f of bx minus ay. So here b and a are one, therefore it is going to be of the form f of x minus y. We got the same format. E power mu x minus y is same format, f of x minus y format. Okay, so therefore we are getting the product solution in this way. So this is one solution. U is one solution. In general, what you can write is that you can write for this problem you can write summation e power mu I e x minus x minus y also you can write it. Okay, summation I equal to 0 to infinity mu x I minus x minus y also you can write it. That is also going to become a solution for this problem. Okay. Okay. Now we are going to solve heat equation. Let's come to the heat equation. Okay, so I'll just erase everything and then we'll complete it and then finish this class. Okay. So in this case, what I'm going to have is similar kind of things I'm going to have. Okay, I'm going to have split it into 3 parts. Okay, so let it be here. Okay. So what I'm going to do, I'm going to split it into 3 parts. So what I have, I am going to substitute it over here. So what I'm going to assume is that I'm going to assume that u is of the form x of x into y of t of t. I'm going to assume. Okay, this is the solution I'm going to assume. Therefore, it is going to imply that ut is going to become like x of x into t dash of t is going to come. Okay, and u xx is going to become like, I'm just directly writing xx is going to become like x double dash of x into t of t is going to come. Okay, so here t dash is denoting with respect to time. So if you want, I can write this t dot also. Okay, that is not a problem. So t dot of t, I can write it. That is not a problem. So if I substitute it over here, this problem ut is equal to c square exx. If I substitute it over there, then what I'm going to get is that I'm going to get it like x of x into t dot of t or t dash of t, doesn't matter. Okay, equal to c square into x double dash of x into t of t is going to. Okay, I can divide that. So if I divide this, what I'm going to again I'm going to what I'm going to do is that I'm going to divide by x of x into t of t, because it is not equal to 0. If it is equal to 0, the product is equal to 0, therefore it is going to be a trivial solution. I'm not interested in the trivial solution. So if I divide this, again that means what I'm going to have, I'm going to have again as x double dash of x divided by x of x is going to come. Okay, x double dash of x by x of x is going to come equal to t dash of t, t dot of t. I can put t dot of t by t of t is going to come. Okay. So I'm going to put the c square is missing. So c square I'm going to keep it here. Okay, 1 by c square. Okay. So therefore what you are going to get is that now again same thing. Okay. So x double dash of x by x of x is there, and t dot of t by t of t is there. This is function of x. This is function of t, and both are equal. Therefore this should be some constant should be there. Okay. I'm going to put that as q. Nu is some constant I'm going to get, because both are independent of. This one is independent of t, this one is independent of x. Both are equal. That should be only possibility is that constant. Okay, other than that, nothing is possible. Okay, therefore, what you got is that you got two problems you got it. One problem is that you got so two problems are there. So problem number one is that you have tt, okay, by dt equal to c square nu, okay, c square nu into t, okay, or I can write this tt by dt minus c square u into t equal to 0. Second problem is that I have d square x by dx square, okay, equal to minus u into x equal to 0. Okay, so two problems are there. So let us solve the second problem first. Okay, u is any constant, any real constant. Okay. So now we have to look at the boundary condition. Let us look at the boundary condition for this problem. Okay, let us look at the boundary condition. So now what I have the boundary condition. Let us look at the boundary condition. So u of 0 comma t, u of 0 comma t equal to 0 means what I have, x of 0 into t of t equal to 0. Okay, x of 0 into t of t equal to 0. If t is identically 0, okay, if t is identically 0, what you are going to get is that if t of t is identically 0, again you are going to get your u is going to be identically 0. Therefore, that is the trivial solution which I am not interested in. Okay, therefore I am going to assume t of t is not equal to 0. If t of t is not equal to 0, what I can get is that I can get x of 0 equal to 0 is going to come. Okay, so that is the first condition. Similarly, u of l comma t is equal to 0. Okay, u of l comma t equal to 0. U of l comma t equal to 0. This is going to become like x of l into t of t equal to 0. But t of t is not identically 0. Okay, t of t is not equal to 0. If t of t is equal to 0, then this is going to become like 0. I am not interested. Once again, what you are going to get is that x of l equal to 0 is going to come. Okay. Therefore, what you got is that you got a problem to solve. The problem is that you have to solve this problem. D square x by dx square minus nu x equal to 0, and then I have the boundary condition for them. X of 0 equal to 0 is there, x of l equal to 0 is there. So this problem I am going to solve. Okay, let us solve this problem. Okay, let us solve, because nu I don't know, nu is any constant. So I am going to see what are the possibilities for the nu. So this is nothing but you can see that this is nothing but the Sturm-Liouville problem. Okay, you can see this one. This is nothing but the Sturm-Liouville problem. So we have already solved this problem. This is the Sturm-Liouville problem, but we are going to see the same thing again and again. Okay, this is the same case for wave equation, Laplace equation, everything. We are going to do the similar Sturm-Liouville problem, and then we are going to solve. So let us discuss case by case. So case number 1 is nothing but nu equal to 0. Okay, suppose nu equal to 0. Okay, then this d square by dx square is going to become like I am going to get x double dash equal to 0 is going to come. Therefore, x is going to become like a, x dash is going to become a, and x is going to become like ax plus b is going to come. So now I have to apply the boundary condition. So if I apply the boundary condition x of 0 equal to 0, then I am going to get b equal to 0, because a into 0 plus b equal to 0 is there. Therefore, b equal to 0. And x of l equal to 0 implies that already b is 0. Therefore, I am getting a l equal to 0. L is a positive number. Therefore, you are going to get L is non-negative number. Therefore, you are non-zero number. Therefore, you are going to get a equal to 0. Okay. L is a positive or positive number because it is 0, L. Okay, it's a positive number. Therefore, you are going to get a equal to 0. So that means what I am going to have, I am going to get x equal to, this is also 0, this is also 0. Therefore, x is identically 0. So if x is identically 0, therefore you are going to get u is equal to identically 0. I am not interested in this case. Okay, I am not interested in this case, because u is a trivial solution. I am not interested in the trivial solution case at all. Now next one, we are going to go for the nu greater than 0 case. Okay, nu greater than 0. If nu is greater than 0, okay, case 2. Case 2, nu is greater than 0. Write this nu as, okay, so I'm just going to write this nu equal to mu square and bracket. Okay, mu equal to mu square and bracket. So in this case, I can write this problem once again, same problem. I can write it as x double dash minus nu square x equal to 0. Okay, so you can see that this is you can see the auxiliary equation. Auxiliary equation is going to become like m square minus nu square equal to 0, which implies m equal to plus or minus nu is going to come. M equal to plus or minus nu is going to come. Therefore, I can substitute it over here. Therefore, this is going to become like x equal to a e power ux plus b e power minus ux is going to come. Again, substitute that value x of 0 if I substitute. So this is going to become like a plus b equal to 0. X of 0 equal to 0 implies a plus b equal to 0, which implies b equal to minus c. Okay. So x of l is going to become like x of l equal to 0 implies a e power ul plus b e power minus ul is going to come, but already b is minus a, therefore this is going to become like a into u power l minus e minus u power l is going to equal to 0. So this is going to be 0 only if nu equal to 0. Okay, 1 minus 1 is going to come, therefore it is going to become 0. But nu equal to 0 already we have discussed. Nu equal to 0 means mu is 0. Mu equal to 0 already we have discussed, therefore mu is not equal to 0. So if mu is greater than 0, okay, nu is a positive number or negative number, whatever it is, okay, because I just assume mu square. So in that case, what you are going to get, your e is going to become like a positive quantity or non-negative quantity. It is not going to become 0 at all. Okay, it is going to be a positive quantity. So in that case, what you are going to get is that you are going to get this is going to imply that a is going to 0. Okay, therefore a equal to 0 means b equal to 0. Therefore your x is going to become like identically 0. If x is identically 0, that means u is identically 0. That means again you are going to get the trivial solution, which I am not interested at all. Okay. So that case, only possibility, we are left with only one possibility now. So that is nothing but nu case 3. Case 3 I am having. I have only one possibility now. Nu is equal to nu is less than 0. Okay, nu is less than 0 means I can write it as nu is equal to minus nu square and write it. Okay, I can write it as nu is equal to minus nu square. That nu can be any real number, then it is going to come. Okay, so in that case, what I can write this problem as x double dash plus nu square x equal to 0. I can write it. Once again, I can find the auxiliary equation, which is nothing but m square minus nu square equal to 0. So therefore, m equal to g plus m equal to plus or minus nu I is going to come. So I can substitute it over here. So I can just write the equation. So x is going to become like a cos nu x plus b sin nu x is going to come. Okay. This is going to be my solution. Now again I have to substitute this one. So if I put x equal to 0, x of 0 equal to 0. Okay. In this case, it is going to become like a plus b. This is going to become 0, b into 0, therefore this is 0, equal to 0 is going to come, therefore a equal to 0. Okay, a equal to 0 means what I am going to have? I am going to have x is going to become like b sin x, b sin mu x is going to come. Okay, now I got to solve this one. X of L is equal to 0, I got to solve. So I solve x of L equal to 0, then that is what you are going to get. You are going to get x of b sin nu L equal to 0 is going to come. Okay, b sin nu L equal to 0 is going to come. Now, if b sin nu L equal to 0, there are two possibilities I have. If I can have b equal to 0. If b equal to 0, again I have x equal to 0 is going to come. I am going to have trivial solution. I am not interested at all. Okay, this also I am not interested. B equal to 0 is also I am not interested. So let us assume that b is not equal to 0. Okay, if b not equal to 0, then therefore what you are going to get? You are going to get sin nu L equal to 0 is going to come. Okay, sin nu L equal to 0. Whenever nu is pi n pi by L, then nu is if I have nu is equal to n pi by L, then this is going to become like LL get cancelled, so you are going to get n pi. Sin n pi is always 0, therefore you can just take n is a integer, n is an integer. So in that case, nu is equal to n pi L is going to be a possible is going to come. Therefore, this is going to become like nu n. I can put it. So nu n is equal to n pi by L. This is called the eigenvalue. Okay, or lambda which you are going to see. Okay, that is going to give me the eigenvalue, so I am going to get it. Okay, so what you are getting is that you are getting in this case what I am going to get is that for each n I am going to get a solution. Therefore, you are going to get xn of x equal to, okay, I am just assuming bn is I can write bn into sin n x I can write, or I can write bn equal to 1 also I can write it. Okay, this is going to become like Cn into sine n pi by L into x is going to be the solution for this problem. Okay, this is the only solution we are having, where n belongs to z. N is positive, n is any integer. Bn into sine n pi L x is going to be the solution for this one. Therefore, what you are going to have, okay, so therefore what you are going to have is that you are going to have if n is less than 0, you can just put x n of x equal to minus bn sine n pi x will come, because sign of negative number is going to become like negative. Okay, therefore you are going to get that. Otherwise, you are going to get x n of x equal to cn is going to come. Okay, so so we are interested on x n of x equal to 0 if n equal to 0. Okay, if n is equal to 0, we are going to get n equal to 0 is going to come. Okay, so we are going to take only the sin n pi by lx is going to, we are going to consider. Remaining thing we are just going to ignore. Okay, so that we are going to ignore. So because this can be represented, the negative side also we can represent the similarly. So therefore, what we have only case 3 is the only case where we have non-trivial solution. Okay, that is when mu is equal to minus u square. So mu is equal to, but what we got is that we got minus n square is there. So mu is equal to minus mu n square is the case which we got from that. Now we solved only second problem. Now we got to solve the first problem. Okay, so this is nothing but mu n square is nothing but minus n pi by L whole square is going to come. Okay, now we solved only the second problem. Okay, so we apply different for each end we are getting different mu. Therefore, now we are going to solve the first problem. So if I substitute it over here, and this is going to become like dt by dt equal to, okay, c square into mu is nothing but minus n pi square. Therefore, this is going to become like plus c square into n pi by L square into t equal to q. Okay, this is going to come. So if I solve this problem, this is once again a simple equation, one-dimensional first order linear ODE. So if you solve this problem, we are going to get your t of t is going to become like, okay, t of t is going to become like e power minus c n pi by L, okay, whole square, c n pi by L whole square into t is going to be. Okay, so this is going to be with some constant I can put, so I can put something like k and I can keep. Okay, this is going to be this solution for problem number 1. Okay, problem number 1 we have solved. Therefore, what you are going to get is that for each n, so you are going to get something like u n of x comma t is going to become like x n of x. So this I am going to call as t n of t, because this is depending on n. Therefore, I am going to call this t n of t. So x n of x into t n of t is going to come. So the solution is going to become like e power. I can write some constant. Okay, some constant is going to come e power minus c n pi by L whole square into t into sine n pi by L into x is going to come. This is going to be your solution. Okay, so I can just ignore this constant. I can ignore that. Okay, without the constant I am writing. Okay, so these functions are called eigenfunction. This is nothing but we solve the the Sturm-Liouville problem and the etc. we have solved. So these functions un of x comma t is equal to e power minus c n pi by whole square into t sin n pi by L x is called the eigenfunctions for the heat equation corresponding to the eigenvalue c into n pi by L. Okay, the corresponding to the eigenvalue c into n pi by L. So this is called the eigenfunctions function. Okay. Now what we have, un of x comma t is the solution. Therefore, you can see that since un of x comma t is the solution, if I just sum it up, okay, suppose if I sum it up, summation un of x t, okay, summation un of x comma t is going to be also a solution, because I'm just taking a linear combination. If I take the linear combination of them, that is also going to be a solution. So those solutions, the linear combination that I am going to test u of x comma t, which is nothing but summation n equal to 1 to infinity un of x comma t, which is nothing but summation n equal to 1 to infinity. I am going to have e power minus n c n pi by L whole square t into sine n pi by L x. So this is called the general solution for our problem. Now we have used only two conditions. Okay, we have used this condition and this condition to obtain this x of 0 equal to 0 and x of n equal to 0. Now this condition we haven't used so far. So those conditions we have to use. Therefore, if I substitute it over here, okay, this is nothing but u of x comma t. If we substitute it over here, u of x comma 0, which is nothing but f of x, okay, so that is going to become like summation n equal to 1 to infinity. I'm going to substitute t equal to 0, therefore this is going to become 1. So I'm going to get sine n pi by l into x is going to come. So I have to call, so I have to remember that I have used so far 1 I have used, okay, but in general u of x comma t I can write as un of x comma t. I can multiply by some constant linear combination. Therefore, I'm going to put something like an. I'm going to keep it here. Okay, so this is also going to become like a. So an sine n pi by lx is going to be the solution. Okay, so this an or the slide I have given here. This is nothing but a Fourier series. You can see that this is the Fourier sine series. Okay, so this Fourier sine series you can use it. Okay, and then you can find the you can calculate what is the ans or the cns which I got given in the slide. Okay, you can just get that answer. So this is the one during the warfare with Napoleon. Okay, in this troop, Fourier got started. Okay, during that war period, once it was in Egypt, he developed this one. And then later period. Okay, so this is the history of the Fourier series. So this is the idea of the Fourier series, and then he developed the one which we described in the last class. Okay, last class, where we discussed about the Fourier series. So this is the one which we have for the Fourier series. So here, once again, we are going to use the same concept. The Fourier series we have already described that. Okay, so ans can be uniquely determined because you can use the orthogonality property of sine mx. Okay, you can multiply that. So you can get that an equal to 2 pi by l into or cn equal to 2 pi by l into 0 till f of x into sine into x by l dx is going to. So this one we have already seen. So I'm not going to detail it more. Here, this fx can be any piecewise continuous function also you can take. Okay, the solution can be obtained by assuming that fx is any piecewise continuous also you can take, and then you can take one-sided derivatives function. You can take all the assumptions whatever you have for the Fourier series. The same assumptions you can use it for here, and then you can solve this problem. Okay, so here you can observe that this problem has an exponential factor. Okay, this is having an exponential factor. Therefore, when t tends to 0, infinity, then only this is going to vanish. Otherwise, at least some heat will be always there. Okay, some small amount of heat will be always there. So as time t tends to 0 only, this is going to become like 0 is going to come. Okay, this is going to become 0 only if t tends to 0. Okay, so this is going to tell me the rate of decay increases with time. Okay, the rate of decay increases with time. So these are some of the problems. You can just model it. Temperature in lately insulated copper bar with 80 centimeter long. That means your L is given. Okay, and initial temperature is given. So f of x is given, which is nothing but 100 sine pi x by 80 degrees Celsius is given. And the ends are kept as 0 degrees Celsius. Means u of 0 comma t is 0, u of l comma t is 0. Okay. So the question is, how long will it take to for the maximum temperature in the bar to drop to 50 degrees Celsius? Okay, assume that c square equal to 1.158 centimeter square. So what you need to do is that you need to substitute it in this problem. Okay, and then you got to find your an and calculate that an, and then you can say like u of x comma t, you can find it. Now when this is going to reach 50 degrees Celsius, that will be. So that is the first problem. Similarly, you can solve the second problem also a similar type of. Okay, so last point I want to highlight, the remaining thing we'll see in the next class. The next one, we are going to solve the wave equation also in the same way. Okay, the wave equation also we are going to see it in the same way. So these are the two problems I have. Two more problems I have. Temperature in lately insulated part with L equal to pi and C equal to 1. So L is given, pi is given, and f of x is given. You can solve this problem. Similarly, here heat generation. So if you have something like a non-homogeneous part, okay, which is a non-homogeneous part, that also you can translate it to proper format, and then you can solve this problem. So these are all the things I'm just giving as an exercise for you, which you can do. The same kind of things you can, the same kind of things you can do it for ux 0 comma t and ux l comma t. So here I have used u of 0 comma t and u of l comma t. The similar kind of formula you can derive for ux comma 0 comma t and u of l comma 0 comma t. A similar kind of things you can do. Okay, so that also you can do that. Okay, so the variable separation for wave equation is going to follow the same thing. We will repeat that in the next class, and then we solve the Laplace equation also on tomorrow's class. I want to highlight one thing for you. What I want to highlight is that, see, if I just give a one problem, Okay, the heat equation problem or wave equation problem, that is going to cover the entire syllabus. Okay, so you can see that. Do you want a first order ODE problem? Yes, it is there. Okay, you want a separable ODE form? Yes, it is there, because you are going to use it over here, or you are going to use it over here for first order separable ODE. You are going to split it into, and then you are going to solve that. If you want to solve that problem on constant coefficients, okay, second order ODE constant coefficient, yes, it is there. Do you want a Sturm-Liouville problem? Yes, it is there, because this is nothing but a Sturm-Liouville problem. It is there. Do you want a Fourier series problem? Yes, it is there. Okay, almost the entire syllabus is covered. If I ask a single question, okay, if I ask a single question, your entire syllabus will be covered. Okay, so this I want to highlight. So that means whatever we developed in this theory, which I already mentioned in the first class, yeah, we have developed the heat equation. For that heat equation, what are the things underlying theory required? So those things we develop and then we solve right now. The same thing we are going to do this